Okay. So I just took the video live. Sorry, I had kind of a little bit of an issue. Were you trying to watch it and stream it in the other lab and it didn't show up? Oh, okay. All right. So it should be. Does it get me now? Man, I was having some issues here. Oh no, it's good. It's good. Okay, it's got me now. One of my cameras froze up. It happened. So for people online, as I was saying, I posted the lab for tomorrow. The lab for tomorrow does not involve your project at all. So I want to just explain myself there a little bit. The reason we did the project early is because I did not know how long it would take for boards to come back from China. But actually, it turned out it went pretty smooth. So that's good. It ended up being, so the first batch of boards is here. It's on the table in the lab if you want to grab it. I haven't checked the status of the second batch of boards, but it looks like they're moving fairly quickly so DHL was able to get it from Shenzhen to here in like 3 days, so that's pretty good. And it was funny because they said their estimated delivery date was like November 25th, or sorry, like December 25th or something. They had like some huge, I freaked out when I first saw their estimated delivery because it was forever, away. But it turns out they were just trying to, pad their, make it so if they delivered it late, it wouldn't be late. But I don't want to get started. If we get started right now just doing the assembly and stuff, it's going to leave the people whose boards haven't come behind. But you are all free to start your assembly. I am planning to, Reza and I were going to try to pull the parts tomorrow morning, so they should be available for you by the time the lab starts. One thing to note, so when the parts are there, the parts that come off the reels are going to be a strip of tape, a thin little strip of tape, and we'll label on one end of that the value of those components. So on one end of those strips, we'll label, this is a strip of 10K resistors. We might put them in a bag or something. When you get those parts for yourself, you're going to have to take scissors and snip off, if you need 10 10K resistors, you're going to have to snip off 10. And then you're going to have to write on that little on the back of that little piece of tape, these are 10Ks or something. So you're going to have to relabel it. So we'll label the big pieces. When you cut them off, you're going to want to relabel them. You're definitely going to want to. We've had students in the past cut off all their components and stuff them in a bag, and then they have all resistors look the same when they're these little tiny black things. Not all of the resistors that we have a little laser printed label on them that tells the value either. So you definitely don't forget to draw the label on it as you cut it. So most of you will be able to sort of take a break. I don't want everybody fighting for the parts. So during the lab, as you're working on it, if you notice that people aren't collecting their parts and you have a break while you're doing it, go up there, cut off the parts you need, put them in a little baggie. You might want to bring a baggie. We have some sort of baggies that you can use, but they're the recycled DigiKey ones because we care, right? We use recycled baggies because we really, really care, but you can use your brand new Ziplocs. Probably suffocated a baby turtle, but we use the reused DigiKey baggies, which are usually anti-static too. So grab the parts, but I don't want the assembling boards for this week to become an issue. Hopefully next week we'll be able to kind of do it as a class. We'll be able to do the board assembly because there's details that I want to go over with people. There's techniques you can do that will save you a lot of headache and hassle. So I'm going to talk about the process you can follow when you're assembling the board. A lot of you might want to not do the whole thing at once. The one tendency students have is they'll put everything on the board. They'll spend 2 hours soldering everything on a board, and they'll plug it in, and then something will go, psst, right, and it'll pop or something, or it'll do something. And it's better a lot of times to, especially if you're assembling it by hand and you're not using a stencil, it's better to just start at the connector. Do the USB connector, maybe do the resistor, then plug it in and see if you measure 5 volts. And then go on to the next thing, right? Add your next op amp, add your components for that next op amp, and you know what? Plug it in, see if you get the voltage out that you expect. So you can do it piece by piece, and the biggest reason you do it piece by piece is if you have the whole thing assembled and something goes catastrophically wrong and something gets burned or something like that, one, you don't know necessarily what it was that caused the issue. Even if you replace the part that burned, well, it could have been some weird little short somewhere else that caused it. So it'll help you identify if there is a problem, where that problem is, when it shows up. It'll also prevent you from getting too far, right? Let's say you accidentally put the wrong resistor there, and you were supposed to use a resistor divider that gave you 2.5 volts, and instead you're measuring 1 volt. Well, it's going to be nice to know that earlier rather than after it's all put together where you say, why is my battery not charging? And now you got to go through the whole process of getting it figured out. So there's some techniques related to that I want to go over as a class. But I am not opposed to any of you once you have your parts to starting the assembly process. If you want to get a head start, you can, but it will not have much support from me because I'll kind of wait till the class time for that. But yeah.
We don't need to put in a request for test points, right? That's just
We should have we'll get baggies of test points. I actually just ordered 1,000 more test points in anticipation. I'm not sure if it's really tough to source test points right now. So the ones I ordered had to be direct from China. Reza ordered those last week. But we do have a few hundred of them just hanging around. That's one thing though where in the past students get a little selfish with test points where like we have these baggies of 100 test points and they'll just kind of like, oh, here's a baggie that I'll use. And they'll keep it with their senior project and they'll never put it back. So we have a lot of students, I think, wander off with those test points. They're actually very expensive if you get they're like 20 cents a piece for those test points if you buy them off DigiKey. Somehow when you get them from China, they're like 1/10 of a cent each. I don't know what happens. There's some magic that happens there. But so I did order 1,000 from China for $20. But yeah.
Did we ever figure out how to properly do the pad removal on when you're submitting a stencil design in off stencils? In one of your videos, you went through and had an issue with file types and stuff like that. Do you have any idea?
I did figure out so the question was if your stencils has too much stuff and you want to shrink down the size, how to make the smaller one? Yeah. So if you follow the process that I followed in the video where I tried to do it was correct until the very end. At the very end, I saved it. Yeah. And what you have to do is when you're in that Gerber, you have to export it. You have to go through the export process and export it as a Gerber again. If you just save it, basically Altium appends on a whole bunch of junk to your old Gerber file. So you have to re-export the new design with the pads missing as a Gerber with the same settings you had with the previous one. So yeah, so that's a good question. Yeah, I did go back and try to figure out what was wrong with that, and that's the issue, is to re-export. So there's other stuff some people like to do, which I don't think it's going to be necessary for this, but a lot of times people they'll do a swell on all the components. So sometimes people will make the stencil pad a little bit tinier than the actual pad. So sometimes they'll shrink the size. That's not going to be important though for the projects that you're doing. So yeah, that's a really good question. But for assembly, one issue is the only microscope soldering station we have right now, we're supposed to, I ordered like 4 microscopes at the beginning of the quarter. I don't know what happened. But the only oscilloscope microscope, the only soldering station microscope we have is the one in Rez's office. And you just have to be careful not to crowd into Rez's office, right? I mean, technically, yeah. So if you're using that, if you need to use a microscope to do your soldering, which some of you probably will, especially for this little fine pitch parts if you're doing that, just try to be courteous to other people, right? If you know there's a lot of people using it, maybe do one part, get it soldered on, and then do whatever, then do your resistors by hand and then test that part and go back. So don't just camp out at the microscope solder station for a million years. Also, don't be afraid to ask for help. So especially if you have a fine pitch part. So Reza and I have soldered fine pitch parts a lot. We're much more, part of like being good at soldering is just being confident that you know you can fix it. So I notice a lot of students, they're not, they're not any, I mean, I'm sure all of you have more steady hands than me, right? I mean, the past year, I've pretty much, my entire diet has pretty much just been Adderall and caffeine, but I'm joking, sort of. The thing's streamed, I'm joking completely, right? But if you want help from one of us for a part, it's okay. It's not, there's no like points deducted if you need help doing a fine pitch part. It's better that than have it ruin the board. And if you start to get frustrated, especially, as soon as you reach that point where your level of frustration with the thing you're soldering, it gets to the point where you're doing a worse job as time goes on because you're seething with anger at this tiny little bastard. That's the point when you really want to stop and just say, hey, somebody else do it, right? It's like the advice they give when you have a baby, right? They say, like, if you have this urge to just make that baby stop crying, you just need to stop and separate yourself. That got really dark, but they actually recommend that. Our pediatrician is like, oh, if you ever feel that, just set the baby in the crib and go for a walk. And I was like, wait, both of us go for a walk? Oh yeah, sure, both of you go. What? Apparently they trust cribs more than parents, just pediatricians. Anyway, so So if you get to that point where you're starting to get frustrated, you're not going to learn anything at that point. Just give it to somebody else, and the next time you try it, it'll be better. And then eventually, you get to the point where you can solder fine pitch stuff without swearing, and that's good. But there's no, I do want everybody to get practice soldering. I don't want people to leave this class without having soldered on resistors and these other components. Try different methods. Try using hot air if you want. Try using, even if you're not using a stencil, you can use solder paste, where you take a needle and you put paste on the locations and put a part in that. Yeah.
Like I heard you mention a stencil. Do we all get those, or do we have to request?
If you want, so the thing is, the stencils actually cost more than the PCBs. So for this class is always one of the more expensive classes in the department. So your lab fees mostly pay for the software and the computers in the lab stations. In terms of fees for consumables, it's very small per class. So this class is always expensive. They always get on my case, and I asked if I could do if I could buy solder stencils for everybody, but it's over an extra $10 per person to add the stencil. So I've sort of told people, if you want one, you can order it. If you order it yourself, it's pretty much the same price as if I order it for you, and that's why we do the stencils. With the boards, if you order it, it's $40. If I order it, it's $5 because we combine shipping.
And those come from China?
No, the boards usually come from the U.S. They're very easy to make in the U.S. The stuff that comes from China is usually the stuff that's too nasty of a process. So it's not expensive to make a board in the U.S. It's expensive to dispose of chemicals. So the biggest reason things are cheaper with PCB manufacture is it's a lot more economical to dispose of the vats of chemicals that are produced there by the process. So same with taxidermy. They don't really do taxidermy in the U.S. because of that. But yeah, so if you want to do the stencil, again, you're going to be paying about $10 out of pocket to get your own stencil, which, nobody needs a stencil. Everybody, either by asking for help from one of us or for just doing it by hand, you can do it. I would say by hand, it's probably going to take you 2 to 3 hours to do your board. With a stencil, it's probably going to take you about 45 minutes to do your board. Sometimes with a stencil, though, after it comes out of the oven, there's some stuff that's messed up. So sometimes if you do rework after a stencil, it almost always has to be hot air and tweezer. So you don't necessarily escape the pain of bridge soldering and things like that just because you did a stencil, but it definitely makes it better. So, but if you want to do the stencil, you can follow that process we did at the end of the one video. Go to Osh Stencil is the one I like. There's other options though. You can do there are cheaper options that do a plastic film stencil and a slow shipping method. I think there are ways to get stencils for like $3 or $4, but there might be kind of a long lead time on it. I found Osh Stencils is usually cheap enough. Stainless steel ones are really nice. So it's really nice to have stainless steel stencils. They squeegee clean, they lift off clean, and it's not applicable for your case, but the stainless steel ones are reusable hundreds of times. So if you did a design and you're trying to sell this thing, which some of you probably could if your designs work, you could probably actually sell them, and you can do the math on the money, right? You're only talking a couple dollars worth of parts for these things. But in that case, you definitely want a stencil that you could scrape with a metal blade hundreds of times before it starts to fade. So. But we'll go more into the details of those soldering methods and stuff when we do the lab for next week. So it's going to be much more attention to the process of assembling and debugging and the techniques for soldering with paste by hand, paste by stencil, soldering iron by hand, hot air by hand. All of that are different techniques that are good to know for soldering and rework. So but that's going to be next week when hopefully almost all of you have your boards in. And for those of you who were on batch 1, again, go check your boards. We had 2 people's boards that got put in the wrong bag. They were sort of similar looking boards. I don't know. So don't just check the name that's on the board. Also really verify that it's the board that you made and that it's got everything there. Last year we had some students with really weird errors. We had some students where all their metal traces on the back layer were gone. It was some strange, I don't know what it was, but we had some weird errors for students last year. So really inspect your board, make sure every trace you expected was there too. So look at your design that you sent to me, look at your board, make sure everything looks like it's correct. If there is one of those obvious errors, it's better for us to get that fixed now than after you test it and realize, oh, I don't have any connection between this and that. So sometimes also, it seems clear that when they're assembling the panels of these, they're taking your board design and they're putting it on a panel with a whole bunch of other boards. And it's pretty clear, it's like a highlight and drag it over and move it to a certain location, because we've had students where like the parts that are on the corner get missed, so it looks like the person selecting it like just didn't quite select everything as they were moving it over, and so it missed like this region of parts or an edge of parts or something like that. So yeah, double check, triple check your board. And that'll be next week. So this week, boost converter. The rest of so my other topics for today were mostly, I wanted to have an opportunity to answer questions that people might have about the homework, if there was any element of it. Several people had some questions. I posted that solution for problem 1. Problem 1 was probably the problem that relied most on prior knowledge that might or might not have been conveyed clearly by me. So I don't teach the class anymore. It does phasers and you know, inductors and capacitors and J omega C's. So so I don't necessarily know what experience you get or what terminologies you use. So I did the work by hand for that. But any questions? Yeah.
So on problem 1, when you're talking about resonance,
Yeah.
what's that relating to? Just like
So yeah, so that's a good question. So when you have the source here, hopefully this shows up. I don't know. Well, hopefully, I think I'm kind of in the way of the camera right now. I'm trying to do this. So when you have the source here, voltage source, going to something like an LC circuit. So when you have a circuit like this, if you look at this voltage out, the plot of this voltage out, hopefully, I'm getting too far, aren't I? You know what? Okay. So the plot for this voltage out is going to look something like this. So there's going to be, so if you were doing a Bode plot for this, a Bode plot, does everybody remember Bode plots? So Bode plot for this, you would just sketch it like this. Your sketch of your Bode plot would have just looked, oh my gosh, ying, wow. Your sketch of your Bode plot would have just looked like this. So it would be kind of a flat line until you hit this certain frequency, and then it would drop. In this case, it would drop by 40 dBs per decade, as it's an LC filter here. But what actually happens when you get close to this point in this type of circuit, you actually will have this, your output voltage will be higher than your input voltage. So if this input here was 2 volts RMS, when you get close to this frequency here is the frequency at which the impedance of the capacitor and the impedance of the inductor are the same but opposite in sign. And so when you hit this point, in actuality, your voltage is going to be higher. Your voltage here is going to be, 2.5 volts RMS. And a lot of students say when they see this, that's resonance, right? This would be a resonance condition. The resonance referring in this part to these have the same impedance, energy is sloshing back and forth between the capacitor and the inductor. And students, a lot of times this seems like voodoo because students say, well, how can this possibly be that you have a 2-volt source that's providing 2.5 volts across your load? Like, what, are you getting free energy from somewhere? And what's happening is, if you're this source, when you have this resonance case, the effective resistance that you see here is less than the 8 ohms of this load. So if I'm the source, I'm actually seeing a resistance that is less than my 8 ohm load. So the energy I'm putting into this is going to be equal to the energy applied across this load. But when we hit resonance, we have 2 impedances that cancel each other out. But this parallel combination, it's not just a full series combination or a full parallel combination. It's actually the resistor being in parallel with the capacitor mathematically is going to make it's going to make the overall impedance of this appear smaller than 8 ohms. So there's no free lunch here. The source is still going to put out the amount of power that's dissipated by this output load. But the way it happens in a resonant case is the source sees an effective resistance lower than the load. And I think just by coincidence, that problem that I gave you, like the data points, the frequency data points were basically like right here and right here on that resonance peak. They were like almost the exact same value. That was not intentional. That was entirely random. But when you do the math, they were sort of 2 points right on the edge of this resonant peak. So if you looked at the frequency in the middle, you probably would have found an even bigger output voltage and an even smaller harmonic distortion there. But for people who are doing that assignment, it's weird. When you solve for two frequencies and they're the identical thing, and then the next one is like fell off the face of the earth in terms of the voltage across the output. But that was just coincidence, right? So that just the three random frequencies that we sampled were like these three, right? It was something like that. It's like same value, fell off the face of the earth. Okay, other questions? Yeah.
So it's a value greater than 1 multiplied by our input,
Yep.
and that's how, that's what.
Yep. Yeah.
Just so I'm understanding it, and from the calculations as well, this is a boost, by the way, because it's increasing, it's not.
Well, no. So this is the filter at the output of a DC. It is a filter at the output of a Class D amplifier.
Yeah.
So the voltage is increasing, but this is not a voltage regulator. It's not a DC to DC switching regulator.
Yeah. My specific question was, so we're getting more because we're storing energy inside that inductor, which then it'll be.
Yes. Yeah. So.
Discharged at some point.
Right, so energy is sloshing back, as this thing is resonating, energy is sloshing back and forth between the capacitor and the inductor. And when we hit that point where the energy sloshes to the capacitor and the resistor, the voltage is higher across the resistor than at the input. And using with resonance, you can get massive increases in voltage, right? If this resistance had been very big, this would have been a high quality factor. Do you remember quality factor? Did you talk about that in 210? So basically, when you have this resonance condition, the sharpness of this is basically determined by how much energy is lost per cycle. If this resistance is very small, if this resistance is very big, you're going to have very little energy lost each cycle. So your resonance is going to you're going to have a very large voltage produced in this circuit.
And then it'll drop off like a rock.
Right, yeah, it's still going to do this, right? You're still going to get that standard Bode plot behavior, but sometimes at these inflection points of Bode plots, you get this craziness, this crazy resonance. So, yeah, there's a lot of terms that define how good that resonance is in terms of quality factor, bandwidth, right? So the higher the quality factor, the smaller the bandwidth of the, yeah. But actually, this is something you got to be careful with when using an LC filter for audio instead of an RC filter. Because an RC filter, you'll never have that resonance effect. With an LC filter, you will. So in this case, this might not be something you want if you're talking about, you might not want to have a higher gain for frequencies between 1 and 5 kilohertz than you have for under 1 kilohertz. So you might, in this case, you might want to make sure that your carrier frequency is way over here and your audible range is here. You might not want to be playing games with this resonance point. And you can see this, like most speaker drivers, you'll see they do hit a resonance point like this in the profile for the speaker driver. Yeah.
Can that damage anything on the output?
Anything. It could. It could if it's not designed for it. Yeah, it could. Okay, other questions about the homework? Oh, I'm going to restart. You're about to be signed out. Okay. All right, I'm going to have to not do any more meaningful answers because I got to call it quits because my laptop's about to nuke my 1 minute and 40 seconds remaining. Then I got to end the stream. Yeah.
Go over question 7.
Yeah. Could somebody have question 7 so I don't have to touch my computer?
Which DC-DC converter would you use to get a negative 9 volt rail?
Oh, it's DC-DC converter for a negative 9 volt. Do I add negative 9 volt rail? Oh, that's a wrong question. I put that on the wrong assignment. Oh no! Well, I mean, yeah. Okay, sorry. So, sorry. In the next week for next homework assignment, we talk about flyback transformers, and we talk about tube converters, and we talk about inverting converters, which is where you get. Oh no! I can't believe I did that with problem 8 too. I had to move problem 8. All right, sorry about that, folks. Well, you have a smaller assignment, except for those of you who already did it, who will have a smaller assignment next week. Yeah, but basically some amplifier topologies naturally invert the output signal. So your options are you can either have a new ground, which is actually some voltage that's other than your system ground, or you have to switch to a different type of amplifier topology. Yeah, sorry. All right, thanks for telling me. You're like, how do I do this? Go, I didn't tell you at all. Yeah. So let me make sure there's not another. Was the problem before that also? Did I mess them all up here? Was it just that one?
I think so.
That one and problem 8. So that were both moved. So.
Problem 5 didn't seem to match what our material